Okay, it's good.
Okay. She's in room 112 with Miss Mills.
Okay.
I forgot to give something back to Jenny.
112.
Do you need to connect to this
Yeah.
TV?
Alright, hold on 1 second. I'm going to connect to that TV over there, and then I'll get it back going. 042028. Is that right?
Yes, sir.
You didn't even look.
42028.
What do you mean there's been a problem?
It's not a problem.
You know it's not gonna work.
That's rude, Mark. Alright, if this doesn't work, sorry in the back, you'll just have to make it do. Alright, 591-332. Work. Maybe.
No.
No one's presenting right now.
I know, but I need it to show up over there. Maybe?
Disconnected.
Yeah, alright, now we can start. So, couple of quick notes. I had to spend a lot of time yesterday.
It's gone.
You might have to do it one more time.
I'm not doing it one more time right now. I'll try to figure it out. Alright, I spent a lot of time yesterday rushing through getting these understanding checks scored and get back to you. If you did not get, or I think I gave one to everyone even if they weren't here yesterday. This is the stack that I have to work on during third and fourth block, third during my lunch and stuff like that. I'm going to try to get all this scored and feedback to y'all before I leave, or leave it with Miss Courtney so she can get it back to you on Monday. I may take some of this with you, or with me, and make scans of it and email it to you. So be on the lookout for an email from me this weekend so that you can get feedback and improve your understanding. Remember, it's not just about scores and grades and things like that. It's about growth and learning. This right here, as a quick reminder while a handful of y'all are writing things down still, this is the rubric for scoring. This is what I have out every single time that I score an understanding check, a homework assignment, anything, because these numbers are not just numbers. If you score anything in the 4.5 range, what does it say in bold above the 4.5 and above the 5? Says what? Clear evidence of your understanding, right? It's paraphrased, but that's what it says. You need to be aware of that, because if you're at a 4.5 or a 5, that means you understand it pretty well. Could you improve your understanding? Or improve your demonstration of your understanding? Yes, right? That 5.5 and that 6 is the clear, consistent, and convincing evidence of your understanding, right? So be aware of that. If you're at a 4 or a 3.5, then bold, it says limited evidence of your understanding. You need to be aware of that so that you can figure out how to improve your understanding. But you also need to be aware if it's a 3.5 or a 4, because those each have a slightly different notation on them and what they mean. So please pay attention to this. I want you to have your rubric out while you're taking understanding checks, and even right now. We're going to go over quite a few of these problems from the understanding check. One thing to go ahead and tell you before I forget again until the end of class, I will not be here on Monday. This is the first day of the semester that I've actually had to take off from me. Everything else has been professional development. My grandfather, my dad's dad, passed away I think at the end of January, beginning of February, and we're doing a celebration of life for him. It's in North Carolina on Sunday. There is no way I'm doing a celebration of life on Sunday and getting back here for class on Monday, so I'll be back on Tuesday. So I'll be out, Miss Courtney will be teaching, she'll be continuing what we've been doing out of the textbook. We all good? Okay. As long as you have through 4 or 5, you'll be okay. You'll have a chance to copy some more of these down when we get going. So we're going to do an understanding check analysis and honestly a reteaching of some of these concepts, because when I scored these, I saw some definite misunderstandings that I need to address very clearly. So be ready to take some notes. That is also why I gave you a blank copy that does not have everything on it, but it does have a good bit, right? A good bit of those questions that we need to go over. You know what I'm talking about when I say the blank copy? It's in the middle of the desk. Okay, Tracy, you gave me a blank look like, just kidding, I got no clue what you're talking about. But maybe you're just thinking about something else. Alright, if we get a chance, hopefully we'll get back to lesson 4. We need to wrap up this unit so we can move to new content. If you're a senior, You only got like a few more weeks left, so I gotta teach you as much as I can before you get out of here. If you're a junior, we got some more to learn after they leave. So don't worry. If the seniors leave, we still learning. Alright. So first things first, degree of polynomial. All of you need to pay attention to this because I think that the key detail about a degree of a polynomial got lost on almost everybody, and we need to pay attention to this. So, when we talk about a degree of a polynomial, a whole bunch of us said a very accurate statement, but it's not what we needed here. A lot of us talked about, or we were close to being accurate, let me say it that way. The degree tells us how many what the function has. How many zeros. Remember, that's actually the fundamental theorem of algebra. Right? The fundamental theorem of algebra tells us that, hey, whatever the zeros are, or whatever the degree is, that is how many zeros that function will have. But does that say that the degree is the number of zeros for the function?
No.
No. The degree simply tells us how many zeros that function will have. So, anybody have, or what do you think the most common response or most common detail next was? Okay? Something about multiplicity, so that does connect to that. It does tell us that the shape is determined by the degree, but what I saw more than anything was, it was the number of x's. Don't write this down, okay? But the number of x's, or something like that. But I want you to pay attention to this. What would be the degree of this polynomial right here? See, that's what a lot of us were thinking. And it's not 15 here. The degree, why are y'all thinking 3?
Wait, no, it's 7.
The degree is 7. Why is the degree 7?
Because the degree is the highest exponent of polynomial, which is not necessarily all of them added together.
It's not always all of them added together. We need to clarify and look at when it is and why that's the case. We need to recognize that the degree is the highest power of the polynomial, and that's it. Okay? The degree, and this is what you should write down, of the polynomial is the highest power. There's one more detail I'm going to add into this. Does anyone know what form of a polynomial we might call this? Typically we do write it in descending order. So when I look at those exponents, I want them in descending order. Does anyone know what that name would be called? Does it remind us of anything from quadratics? Does it look like a factored form? We would call that standard form. Just like with a quadratic, ax squared plus bx plus c. That's very similar. So, this would be called standard form, as seen in standard form. A lot of y'all we're mostly used to thinking about factored form. But the highest power is seen in standard form most easily. We're going to address what it looks like in factored form in a second. So, we are forgetting something in blue up there. I'm going to come back to that in a second. Well, yeah, I'm about to show you something that's going to help you understand the blue part up there. So, anybody know what the degree of this function might be? Is that my box? Okay. Just leave it back there and then remind me about it 3rd o'clock. Anybody know what the degree of this function might be? Okay, why do you think 2? So, but notice that exponent is not directly on the x, and also, we're multiplying here. Actually, I'm going to come back to that one. Hold on. Sorry. I will come back to that one. Let's look at this. What would be the degree of this polynomial? The degree of that would definitely be 2. How do we know? Okay, I want you to notice, this is in factored form, right? So, I could distribute here, correct? And so that would be x squared minus 4x. So when we distribute and we get that standard form, the highest power is 2. So that would be a degree 2 polynomial. Okay? What about if it was x squared minus 3 times x plus 4? What would that degree be? That would actually be a degree 3. Okay? Because what is this one right here?
Quadratic times a linear.
Quadratic times a linear. So that's going to increase it by how many? 1 to a cubic. What if this was x to the 3rd though? What would the degree be now? Degree would be 5. Now, my guess is someone has a question about that. Anybody? So we completely understand why. Let me ask this question then.
Can you explain that first one?
This one?
He said he was.
Oh, this one up here? Yeah, I'm going to come back to it in a second. First off, I want to point out, we're going to learn more about this on Monday probably, maybe at the end of class today. We will distribute, right? And x squared times x to the 3rd is x to the 5th. X squared times 4 would be plus 4x squared. Negative 3 times x cubed would be minus 3x cubed, and then minus 12. Notice I'm literally just distributing. Are there any like terms here that I can combine and simplify?
No.
So we want to be careful and we want to pay attention to this and remember, right? This is 1x to the 5th, meaning I have that 1x to the 5th. This is 4x squareds being added, and this is subtracting 3x cubes. So are any of those exactly the same? No. Notice if I had 3x squared plus 5x squared, I'm adding how many x squareds? 3. Remember, multiplication is repeated addition. It's going back to those fundamentals. I'm adding 3x squareds. Here, I'm adding 5x squareds, which gives me a total of 8x squareds. So we have to be careful about that. It has to be the same power to be able to add those coefficients because of what we actually mean by multiplication. So, why in the world, and I need to clarify this, because you need to fully understand this, why is x squared times x to the 3rd equal to x to the 5th?
Because when you're multiplying variables with exponents, you add the exponents.
Why?
You just do.
You just do, right? That's what we've always been taught. So not sure? Because here's the thing, you say that. But what if I had x squared times a cubed? Would I add those exponents?
No.
So there's got to be a difference there, right? What do I really mean by x squared? That's x times x, right? What do I mean by x cubed? Wait, so I had 2 x's being multiplied, and I multiplied by 3 more, so I have a total of 5. That's what's really happening there. It's not magical, it's logical, right? An exponent tells me how many times I'm repeatedly multiplying. That's it. Well, here I have 2 x's being multiplied, and here I have 3 a's being multiplied. Can I add those exponents, or can I combine those at all? No. That's why I can't add those exponents. They have to have the same base, because literally, I'm increasing the number of x's being multiplied. And if we increase, we end up, what's math? Say again? Adding. Right? Addition is the idea of increase, right? That's why, this isn't something I'm going to be testing on anytime soon, but you need to know this because it will come up. if I divide by 3 x's, x to the 7th is this. 2, 3, 4, 5, 6, 7. Dividing by x. Hey, what is x divided by x? Anything divided by itself is what? 1. X divided by x is 1. And then x divided by x is. So how many x's am I left with?
4.
So when I multiplied with the same base, I added the exponents because I was increasing the number being multiplied. When I divided, I was subtracting because what was happening to the number of x's being multiplied? It was decreasing, right? It's not just magically made up rules. All of mathematics have a reason behind it. That's why it's x to the 4th. So that's why when I see x squared times x to the 3rd, I know that's going to be my highest power, and so I know I'm going to have x to the 5th. Okay? But let's make this one more step. Anybody have a guess what the highest power here would be? Not x to the 5th, not to the 10th. So what's x squared times x cubed? Remember when we're multiplying, we're increasing, so we're just going to add the exponent, so x to the 5th. Now we multiply here. What's x squared times 4x to the 5th?
4x.
Be 4x to the
8. 7.
and we're going to add them, right? We have 2, and we're increasing by 5. Okay, so what's my degree then? 7. Notice it's going to come from the highest degrees of each of them because we're multiplying. Okay? So what are your questions from there? So, I don't remember who it was who said that they want me to come back to you. Was it Keyshawn? You the one who said it? Okay. So, the reason why I said we need to clarify this detail right here. What are my zeros in this case? So x equals 3, and x equals what? So remember, this is why we always want to set those factors equal to 0, right? And when you solve those equations, you get 3 and -1/2 actually. We're going to deal more with that later, so I'm not going to spend a ton of time there. But that's only how many zeros? But what degree is that polynomial? So how many zeros should I have? So what gives?
You got x minus 3 twice.
Okay, x minus 3 twice. So it's x equals 3 with,
X minus 3 times x minus 3.
not multiplication, with a multiplicity. Yeah. So that's what we call it because it's how many times it's happening, right? With a multiplicity of 2. So remember, it's not just the number of zeros, it's the number of zeros when including the multiplicity. So how many zeros the function has when including the multiplicity? But be careful and remember, the degree is not the number of zeros. It tells us how many zeros. But the degree is not the number of zeros. It tells us how many zeros. The degree is the highest power as seen in standard form. This part right here is the most important detail. The degree is the highest power as seen in standard form. It tells us how many zeros the function will have when we include that multiplicity. Does that add clarifying detail that we needed? Make more sense so we understand it better? Asia?
I'm tired.
Trying to get you wake up, come on. Start smiling, laughing a little bit, it's gonna wake you up a little bit. Come on, we need it. You get those endorphins rushing, and it's, you know, there's nothing like it. Every time I step up to teach, just get those endorphins rushing. I like doing this. Anyways, any questions, or what are your questions before we continue? Tamia, what you got?
I don't understand why you didn't add
The exponents?
for the 8 to the 3rd. Because they have the same coefficient. So I don't understand.
Wait, It's, okay, be careful. It's not about the coefficient. If I have 2x squared minus 2x cubed plus 3x squared, what this right here means is x squared plus x squared, right? This means minus x cubed minus x cubed. Even though those have the same coefficient, I cannot add those or subtract those. This has a different coefficient, but that's what we really mean. So how many x squareds do I now have?
5.
And if I'm repeatedly adding, what can show that repeated addition? So that's 5 times x squared. Those cannot be added to x squared because they're not the same. So minus 2x cubed. It's not about the coefficients being the same. It's about the power being the same. Has to have the same base and same exponent to be able to add and subtract. Does that clarify? Okay. And then remember, we only add the exponents when we're multiplying powers with the same base. Okay. We good with that detail? So thank you for that question. That's that active collaboration, those questions, the sharing of thoughts and ideas that I am consistently looking for. That's when you're going to learn the best and the most and all that stuff in between. What are your questions before we continue? Alright, we're going to flip over to the back side right now because I realize that these questions go together a little bit better than doing the bottom. We'll get back to the front in a second. I don't think this will take us as long as it did in the first block, but we'll see. So y'all first off have got to read your question. Number 9. I was asking how many x-intercepts what function has. G of x. What is g of x equal to though? A whole bunch of y'all just looked at f of x. A whole bunch of us. So we did not read our question. Instead, g of x is equal to what?
X times.
We already have that, but how could I rewrite that? X plus 5 times x minus 3. Right? So how many zeros does that now have?
3.
Or x-intercepts? It has 3. Because what degree is that function?
3.
It's cubic, or a degree 3 polynomial, right? And you could have also, in showing even more evidence, right? I could have shown, hey, x equals 0 is a 0. X equals negative 5 was a 0. And x equals 3 was a 0. Positive 3 equals, that's a 0. So, how many, now I do want to clarify and point out, what have I shown? Have I shown x-intercepts?
Yes.
No, zeros.
Shown zeros. Remember, an x-intercept is a
Point.
point. It's a small but important difference. I've shown zeros, but we know that every 0 will also be an x-intercept. Right? Or every real 0, I should clarify. So we want an x-intercept, so there's 3. What are your questions before we continue? So to build a little bit better understanding, especially based on a really good question Ms. Courtney brought up and some students also had in the first block, I want to point this out. What if f of x equals x plus 5 times x minus 3 is exactly what we started with, but now we're dilating by x minus 3. So now what would g of x equal?
I mean, yeah.
X cubed.
Well, it'd be a cubic, but I'm asking what would be the equation for g of x this time? X minus 3. How many x-intercepts and zeros would this function have?
3.
2.
I
Yeah.
have 2.
Okay.
Say that one more time. We got a double root here. We got multiplicity in this case, right? Notice from this 0, or from this factor, I would get what 0? X equals 3. But wouldn't I also get the same from here? So that would be x equals 3 with a multiplicity of 2. And then from here I would get x equals negative 5. Notice that would be an x-intercept of 3, 0 and negative 5, 0. So this still obeys the fundamental theorem of algebra. It's a cubic, a third degree. And when I look at my zeros and count the multiplicity, do I still get 3? Right? So 1, 2, and 3. But only 2 x-intercepts. Yes, ma'am?
So if you ask a question like that on the test and we put 3, it would be wrong.
Well, it would be wrong, but depending on your level of justification, you can still earn decent points. But it is important, that's why you have to justify, right? You need to show me your level of reasoning. Justifying is that idea of, here's the evidence for why I said what I said. This is why I'm thinking this. And so, you can just be off a little bit in your conceptual understanding, but you get a very different, or very wrong answer, but still have pretty good understanding. And so, like if you were to look at it and say, well, it's got to have 3 zeros because there's 3 linear factors, that's pretty good understanding. You're recognizing that the zeros come from the linear factors, right? But we would want to notice in a problem like this that this 0 has a multiplicity of 2, so there's only going to be that one x-intercept associated, and here's another x-intercept, so that would only be 2. Do we understand that?
Oh, I
Go
see,
ahead.
I see. So if the question was how many zeros, it would be 3.
Still 2. Because remember, this, and so here's one thing to clarify, and when I ask how many zeros, what I'm asking is how many distinct zeros, and so what I mean by that is how many different zeros are there. So even though we have x equals 3 and we have it twice, it's still x equals 3, right? And so that's what we want to recognize there, that it's still an x equals 3. And that's why, like, if you were to graph this, this is not going to be super accurate, but it's going to look something like this. So it's going to have that x-intercept, and then it's going to come, and remember it's double root, so it can't pass through, it's going to touch, and then go away, right? It's only going to have those 2 x-intercepts, those 2 zeros. Make sense? So it's how many different numbers they have. But that's why the fundamental theorem of algebra tells us we have to also look at the multiplicities. So there's still 3 values when we count the multiplicity, but it's 2 distinct numbers. Okay? What are your questions? By the way, if you didn't get to number 9 and copying this information down, notice it's right there. Here's the notes for number 10 about where you can find this. But once again, on number 10, y'all got to pay attention to your question. Does number 10 ask you how can you determine the number of zeros in number 9? No. Yeah, how do you determine the zeros? So what are the zeros is that question, and how would you identify them? And a lot of us talked about x-intercepts here, which, can you find zeros from x-intercepts? Heck yeah. Did y'all have a graph here to be able to determine those zeros? Heck no, right? You didn't have a graph. Now, if you'd gone into the detail of, I graphed the function in the calculator to get the zeros, bet, cool. But don't forget, this is called a what again? Say again? Well, yes, I understand. I just meant, like, what are we looking for here? What does it ask for? A 0. What do we do to find zeros? See, we need to be careful there. Alright, so I'm going to write this up here. And again, we're dealing with g of x equal to x times x plus 5 times x minus 3. If you did not hear what Chloe said, this is a great misconception to learn from. She said, hey, we're going to set x equal to 0, which means x equals 0. And so we get g of 0 equals 0 times 0 plus 5 times 0 minus 3. That would give me the point 0, negative 15. That's what we mean when we say set x equal to 0. But what kind of point is that? Say it louder.
Y-intercept,
How do you know it's a y-intercept?
x0.
The x is 0, right? We have a y-intercept if that x value is 0. Is that what we mean when we talk about zeros? So am I setting x equal to 0? So I'm going to talk about both those ideas. You're not wrong. I need y'all to listen to this. What we have always said up to this point is that we're going to set the linear factors equal to 0 every single time, right? That's what I would do. In general, right, so I'm going to write this answer up here. What we are doing is set, and I'm going to take off the word linear. I'm going to say set the factors equal to 0. There's a reason why I'm taking off the word linear, and I'll show you why in a second. Notice g of x equals x times x plus 5 times x minus 3. So, yes, in a way we end up, for this particular problem, setting x equal to 0. But we also set x plus 5 equal to 0 and x minus 3 equal to 0. So is that it? We're done? We just set the factor equal to 0? What do we still need to do? And we have to solve the equation. So showing this is what would have also gotten you up to a 6, but this is the majority of what you needed to say for number 10. So do you notice for more space I brought 10 up to here? Okay? What are your questions up to this point? So I need to cover 2 more details that I want you to see. Anybody else hot, or is that just me?
It's just you.
Thank you, alright. If I'm not the only one, I'm not gonna like crank it down to 65, I'm gonna do like 68 or so. Alright. I just barely turned it down. Alright. So, questions? Going once? Going twice? Sold. Alright, let's look at it. There's 2 things I want to point out about this. Does anyone know why I dropped the word linear off of being in front of that word factor? It does not always have to be linear. Okay? For example, and so that's a big thing to notice, it does not always have to be a linear factor. It could definitely be, so just note this is extra for numbers 9 and 10. Let's say that I had y